Let's learn about order of an element. This is a very important topic in number theory, and in fact, it is also related to group theory. And in our level 5 or 6 of Mathematics Olympiad program, we learn it in the context of group theory because that gives it a wider conceptual depth, and we can use it in a variety of situations. But to learn this, we will be using a motivating problem because otherwise we don't learn anything. Just looking at theory really tells you nothing. So the motivating problem is this: find smallest positive integer n such that 17 to the power n when divided by 2 to the power 2005 gives remainder 1. Okay, so if you divide 17 to the power n by 2 to the power 2005, you get remainder 1. You want to find out the smallest possible positive integer n such that this happens. So by learning about order of an element, we hope to solve problems like this. This problem is from Titu Andreescu's book on number theory structures. It's a very beautiful book. Number theory structures. We use it in our level 5 and 6 of Math Olympiad programs. Okay, let's understand what is order of an element now. A very simple concept. I'll go to a new board now. I'll understand this using an example. Let's take the number 15. We will build a set of all numbers which are less than 15, positive integers which are less than 15, and which have highest common factor 1 with 15. Sometimes these numbers are known as co-prime to 15 or relatively prime to 15. So what are those numbers? 1, 2, 4, 7, 8, 11, 13 and 14. Notice that each of these numbers have HCF 1 with 15. 4 has HCF 1 with 15. 7 has HCF 1 with 15 and so on. These numbers are known as co-prime to 15 or sometimes known as relatively prime to 15. So you have to say it's relatively prime to what? Co-prime to what? Otherwise it doesn't make any sense. Because you have to know you are computing HCF relative to what. Okay, now that we have this set, we will define an operation. In fact, sometimes known as binary operation. We call this operation star, and I will tell you what it is. If you take any two elements, 7 and 8, let's say, again an example, and if you want to compute 7 star 8, then it is a two-step process, step 1 and step 2. What is the process? You first multiply 7 with 8, you get the product, which is 56. Step 1 done. Step 2 is you divide 56 by 15, this base number 15, and you look at the remainder. The remainder is 11. That's the final result. So you say 7 star 15, 8, is 11. Those of you know modular arithmetic, what I just did is simply 7 times 8 modulo 15. So the star operation is multiplication modulo 15. If you don't know modular arithmetic, then this is what you can think. Step 1 is you multiply the two numbers. Step 2 is you divide the product by 15 and get the remainder. This remainder is the result when you do 7 star 15. Okay, 7 star 8, I'm sorry. So you get, if you combine 7 and 8, you get 11. So that's what the binary operation is. So you can do the binary operation of 2 with itself, 4 with itself, 7 with itself, and so on. So let's do that. Let's do the operation of an element with itself. So if you star 4 with itself, you can write it as 4 square in a shorthand. But remember, the operation is star. Then what do you get? Okay, you get, step 1 is 4 times 4, you get 16. That's step 1. You divide 16 by 15 and you get the remainder. That's 1. That's remainder is 1. Okay, so 4 square you can then write as 1. I will just use 3 bars to remind you that this is not normal multiplication, it's this star operation. So 4 square, we often say that 4 square is congruent to 1. Sometimes we say congruent to 1 modulo 15. So now we come to order of an element. Order of 4 is 2. Why is that? Because that's what happens if you raise 4 to the power its order, you get 1. Any element raised to the power its order, of course, under the star operation, gives you 1. That's the definition of order. If you raise it to the power order, you will get 1. Okay, so let's look at the order of 11. The order of 11 is also 2. Why is that? Notice that 11 square is 121. If you divide 121 by 15, the remainder you get is 1. So you can write 11 square is congruent to 1. So order of 11 is 2. Order of 11 is 2. If you look at the other elements of this particular set, there are elements like 7. There are elements like 13 whose order is not 2. In fact, can you tell me what are the orders of each element in this particular set? I just computed that the order of 4 is 2, order of 11 is 2. What is the order of 1? Well, if you raise 1 to the power 1, you get 1. So the order is 1. What is the order of 14? You can check the order of 14 is 2 as well. But the remaining elements, what is the order of 2? What is the order of 7? What is the order of 13, 8, and so on? Can you check? I will do one of them. Let's look at the order of 2 modulo 15, or with respect to 15. What is the order of 2? Well, 2 to the power 4, you can check, is 16. You multiply 2 with itself 4 times, you get 16. If you divide that by 15, the remainder is 1. So order of 2 is 4. Because if you raise 2 to the power 4, then you get 1. It's congruent to 1 under that particular binary operation, that star operation. So order of 2 is 4. Order of 2 is 4. Okay. So what do we get? I will ask you to find out the order of 7, 13 and 8 in the comment. Give it a try. And if you can find out, put it in the comment. But notice that the order of the elements that we have found so far, order found so far are 1, 2, 4. Now all of these values divide the number of elements in the set. That's the main theorem. If you look at the set, there are 8 elements in the set. 1, 2, 3, 4, 5, 6, 7, 8. And each of these orders that you have found, they divide the number of elements in the set. That is the main theorem that we have in mind, that the order of any element divides the number of elements in the set. In this case, that's 8. 1 divides 8, 2 divides 8, 4 divides 8, and so on. This is a very deep result that can be proved using group theory. We do it, in fact, in our number theory modules, and it's a fascinating journey into group theory. It can be proved without group theory as well, by elementary number theory, but then you are restricted to only this type of set. In fact, we observe, or those who are initiated to group theory, we observe that this particular set actually forms a group, and sometimes this group is known as U15. The order of a group, order of an element divides order of a group. That is, order of a group means the number of elements in the group, and that is the main theorem in disguise. So we will be using that result, and we will learn how to solve this particular problem, this motivating problem here, in the next video. For the moment, can you find out the order of the other elements in that particular set? The set of 1, 2, 4, 7, 8, 11, 13 and 14. Okay, so give this a try, put a comment in the description, and I will see you in the next video.